Let's get started. Hi everyone, my name is Samia Durissetti, and I'm very excited to present today about dynamic loading in Presto C++, a deep dive. Let's get started. Now, before we go into the promised deep dive, I do want to talk about two key terms, and those are fenced and unfenced user-defined functions, or UDFs for short. Now, fenced and unfenced UDFs are very similar, with one key distinction that makes them work completely differently when it comes to our considerations. So a fenced UDF runs in a separate process than your parent process, let's say the worker, and it connects to you using remote processes such as IPC, PCP, etc. And now the important thing to note with this is that let's say there's any problem that's going on with whatever UDF you wrote or any other issues going on in this remote process, it will never affect your main process, the parent process, which means that you can have the peace of mind, if you will, about none of your main work or none of your coworkers' works being affected by whatever you are doing in running this separate process. And what that leads to is better security, some more peace of mind, of course, but it can also lead to slower performance and higher cost because you have this extra piece to maintain. Now let's look at unfenced user-defined functions, UDFs. Now, unfenced UDFs run in the same process as the worker that you're running. Now, that does mean, yes, there is higher performance and lower cost associated with this. But if there are any problems with, say, buggy code or any security implications, then it can crash the whole worker process and it can affect not just your own work, but other people's work as well, if they are running on the same worker as you. So that's kind of the main differences. And of course, the considerations of security, performance, and cost may lead one person to use a fenced UDF and another to use unfenced UDF. But us, we try to answer for both. However, this particular presentation will be focused on unfenced UDFs. So now, what does unfenced UDFs in Presto C++ look like? Now, that's a great question. Um, Unfenced UDFs in Prestissimo is going to be part of the Fusion Next project. So that functionality is also dependent on other aspects of Fusion Next project. So I'm sure you had a chance to catch my colleagues Pramod and Pratik's presentation on enhancing Presto C++ capabilities. But if not, do be sure to check it out if you want to learn more about these other pieces of the Fusion Next project that make this unfenced UDF a reality. But you don't necessarily need to know how Fusion Next works to be able to follow along with the rest of this presentation. Okay, so now let's paint the picture. Exactly why do we need this? In the past, C++ function registration was done statically, which means we would hard code the registration and we would have to rebuild the entire binary for a single UDF. Now, if anyone has had the opportunity to build Presto on their own, it takes a long time. It is very time consuming. And the other part about having to do things in a built-in format or a static format is you have to have some level of understanding of the code base and where everything goes. And that can be challenging and time consuming when all you want to do is have a UDF that you just want to be able to run with your query. So our solution was to add the ability for users to dynamically load any custom functions that they would like. Now, for example, you think that some geometry function or some AI function that you've seen is cool and you would like to use it in your own flavor of Prestissimo to make your life easier, you can just go ahead and add that custom function in using this functionality. Now, let's look at the use cases, right? Any of these scalar functions are going to be very easy to use. And in addition to that, you have more modularity of your logic, which just simply means you have more separation between the custom stuff that you implement or your colleagues implement and the actual core engine's functionality. And that keeps things neat and it keeps things separate and nice where they need to be. And the other thing that I was kind of hinting at was you do not have to rebuild all of Presto anymore just to register one new function. And having this enables this whole new world of plugin architecture, and there's just so many different ways that we can eventually take this. Now, when we were looking to design this unfenced UDF library, we wanted a plugin interface that was stable and easy to use. And as easy to use as possible. A lot of emphasis on that. In addition to that, now this unfenced UDF stuff is something that is currently offered in Presto Java. So we wanted feature parity with Presto Java by adding this capability in the Presto C++ side. And the other few considerations was we wanted the user experience to be flawless. We wanted it to be very simple for the users to be able to add their custom function without having to learn too much about what's going on to be able to get started. Also, we wanted to make sure that if there were any missing symbols or anything like that, users could gracefully fail if needed. Okay, so let's go a little bit into what this process looks like from a design standpoint. So the query side, the query processing side of things looks like a little bit like this. So the user is going to create these little clouds are basically your plugins. And now your plugins are going to be shared library files, which in, let's say, Mac OS operating system looks like a file with the extension .dylib, but in Linux architecture, it is going to look like a file with the ending extension .so. So now you will have a bunch of these plugin libraries that I will teach you in a moment how to create. You're going to feed them into a plugin folder into your all of your Prestissimo workers. And once you do that and you launch your workers, what it will do is internally, it will take a glance at every single plugin that sits inside of this plugin directory, and it inside the dynamic loader, and it automatically is going to take care of loading all of these into the system for you. So, if everything goes well, you should be able to as soon as you run your workers and your Presto server, you should be able to use these custom functions. And just as easily, you can get rid of a plugin and you no longer see that function anymore. So that's kind of a high level overview of that. And I do want to mention one thing is that going back to the Fusion Next thing, this functionality only works when Sidecar is enabled. And moving on, I do want to show you another way of visualizing what goes on as well. So, for all of my friends looking here on how to actually put these plugins in, let's take a look at two examples. So, looking at the example on my left in the blue, we can see the Docker file setup that is shown up here. So, not the root directory, but under /opt/presto server. Let's say you're going to put your plugin directory where the etc directory is, because logically, that's where I think my plugin directory should go. So I'm going to create my plugin directory right here, over here, as you can see. And then that's where I'm going to place all of my plugins, plugin files. Right. In addition to that, there's also an etc directory inside of /opt/presto server, and that's where all of your other subdirectories, files, and so on kind of sit. Now, in this kind of setup, you would need to do one thing, which is add the custom plugin path, and I'm going to teach you very soon how to, and configure that into your config.properties files for all of your worker configurations. Now, as soon as you do that, the worker is going to be able to look into this plugin directory to be able to properly load all your plugin files. Now, let's look at another flavor of this directory tree, right? So this is going to be a different process, not the Docker file process, but a different one. And let's say the setup looks a little bit like this. You have the root directory of the process, or just slash, if you want to be technical. And inside of that, you're going to see etc, the bin directory, and then now the plugin directory. And now inside of this etc directory, you're going to see catalog and all of your other subdirectories and files. And within this plugin directory, you're going to have all your plugins. Now, in this case, you can use the default plugin path because the plugin path, if you do not show a custom one in the config.properties file, is going to look in the root directory of the process for a plugin directory. So that's kind of two ways to visualize how this looks like in sort of real life examples of how we use Presto. Okay, now let's get into actually how to use a custom function. So I know that I promised you beautiful, clean user interface. And if you're saying, Samia, what is going on? What is all this code? Then I want you to hold your horses for a second because as you can see here, the highlighted pieces over here in orange are what you genuinely have to worry about for your own creativity, if you will, and your own use cases. So naming the struct and figuring out what your return types and argument types are something that hopefully you can customize on your own. Additionally, the actual function body is completely dependent upon your use case as well, which I would hope you would be able to customize over there as you please. But anything that you do not see here on the CPP file that I've highlighted here is essentially boilerplate code. So I want you to see and understand that this is mostly copy paste stuff. And what you need to understand is how do I register a scalar function in VLOX? And there's tons of documentation that I've linked in this presentation for you to take a look on how to create these functions from like the VLOX API perspective, um, to answer questions such as, hey, why is there a bool call here? And stuff like that. And also, from the dynamic library loader perspective, there's a ton of examples you can also access to see what kind of functions you can use and how you can take this dynamic loading capabilities to make your use cases. So that's the C++ side. And on the right side over here is just how to take the C++ file and create those, what I mentioned as shared libraries, the .sos and the .dylib files. Now, all you have to do here is, again, take the file that we called today dynamic function.cpp, and then you give it a name that you would like to call your dynamic function library, and then you add these flags that are necessary to hook these up. And other than that, this is all boilerplate. So now that you've written this function and you've compiled it and you have a shared library in your hand, you would have to drop these libraries in the plugin directory. So that location can be, like I said, customized. And to do so, you set this property called plugin.dir in each of the worker's config.property files. And that's all you have to do to make that customization. Awesome. Now that you've dropped all your files in your plugin directory, you've created all your files you wanted, and all your shared libraries are where they need to be, all you have to do is start your workers, start your coordinators, and relax. Okay, so is it actually that easy? Let's take a look. Let me do a quick demo for y'all to show you the capabilities. Okay, let's go here. So I took the liberty of creating a function in a file called dynamic function prestocon.cpp. Now, what today the function we are going to be writing is going to be to calculate the area of a circle. So a quick math refresher for anyone who wants it to calculate the area of a circle, last time I checked, is pi r squared or pi radius squared. Okay, so now how do I do that? Firstly, I'm going to take the boilerplate, and then I've already taken the liberty of figuring out what my return types are going to be and what my argument types are going to be. I would like one radius argument as a double passed in, and then the result type, which is going to be a double. So that's going to be the area that I'm going to be returning. Right. So all of this is set up, and like I said, similarly, these doubles are going to match these doubles over here, and the name of this struct has to match the name of this struct here. So now that all of this is taken care of, let's see if I can figure out how to write the code for this. So, oops. So the result, we are going to set that equal to, um, there we go. So as you can see, pi is 3.14159 something something. I'm just going to grab this value. And then I'm going to multiply it by the power of the radius to the power of 2. Okay, so let's check our work. I think that looks right to me. Result matches with result, and I think I have the capabilities that I needed to express with this function, and I'm gonna go ahead and check here. So we need a call to register extensions here. That is necessary for the dynamic library to resolve and load this symbol. And inside here, I'm going to call my function dynamic circle area. Now, if any of this call method and any of this is confusing on how to actually do the registration part of this function, then go ahead and take a look at the documentations that are linked here for how to do scalar function registrations, and it will be very, very helpful, I promise you. Okay, now that this is done, I'm going to um, do what is called make debug. And as this happens, let's take a look at how I added my circle function. Over here, I added my file name, which I told you was dynamic function Presto C, looks good. And then I added to the boilerplate all the test link libraries that I needed. And then I added to the boilerplate all the flags that I need for this to work in Apple and Linux. So, ooh, let's see. I think there was an error. So let's take a look. That's strange. Oh, it's because I'm in the wrong branch. Okay, now let's do this. Now it should work. Okay, sorry about that snag. I was just working out of one of my branches that I did not need. Okay, so now that the build is done, let's go ahead and see if this actually works. So off screen, I had a chance to set the plugin.dir path to the path that of the plugin directory where all these shared libraries got created. So now that that part is also taken care of, all we have left to do is running the Presto server, the sidecar worker, and seeing if this process worked or not. So let's get started with that. As oh, as you can see, the Presto server has already started. I'm going to start the worker over here. Ooh, this is interesting. Okay, so let's take a look at this. So there's some log statements here that say that the library was loaded and this is the path where it was loaded from. And it is going to search for the path that I told you, the register extensions path. And now it's showing us that it is registering the functions that we have seek to register, and there it is, dynamic underscore circle underscore area is right there. So now, if this worked, then I should be able to put it up to the test and be able to run this function, because that's what I promised for you to be able to do. So first, we're going to run Actually, let's do a show functions call. So what I just ran right now is a show functions like dynamic percent. What that essentially does is it looks through every single function that was registered to this worker, and it is going to, that is registered to our current run of the server, and it looks through it and it's going to look for everything that has dynamic in the name of the function. And lo and behold, dynamic circle area is there. So then I am going to take my favorite number mm, and add 3 to it. So I'm gonna take this number right here. Let's do 21.0 and see if a circle of radius 21 is going to give us the right output or not. So let's do a select statement for this. All right. Oh, let's see if that is right. Okay, so assuming that pi is 3.14, sorry about that. I'm going to take that and then 21 times 21. Yeah, that sounds about right to me. Okay, awesome. So that is the end of this demo. So let's head right back to the PowerPoint presentation. So even though this process is easy to use and convenient, there are some concerns to be reckoned with the dynamic unfenced library loading. One such concern is unverified code execution. So technically, anything could be loaded into this as long as the register extensions function call exists. And now that is a known security issue that the users are aware of when using unfenced function loading. And they understand that this is something that they have to deal with when it comes to this functionality. And in addition to that, there is also concerns with ABI compatibility. So if there are any inconsistent versionings between the versions that these plugin shared libraries are in and the Presto is in, that can lead to some weird ABI mismatches. And to mitigate that, we do ask users to, every time that they um, update their versioning on their Presto, to go ahead and also recompile all of their shared libraries to avoid this problem. And the other thing also is for those of us who enjoy to debug any of their errors, it is harder to observe these functions and test because they are introduced in such a different way. So, to mitigate all of these issues, we try to provide clear documentation, simple user experience, and tons of logging to help the user with any of these issues that might come up. Of course, there are future improvements to the user experience that are planned and to the actual dynamic loading capabilities to be able to make the validations and security aspect a little more robust. Speaking of, what is the future roadmap? So I did mention that you can add your UDFs in, but right now we do only support scalar functions. So our next steps are going to be to add aggregate and table value functions. And in addition to that, one of our other key points in the future roadmap is to overhaul the plugin installation, hopefully take care of the security side of things and make it a little more secure to use. And those are all currently in the works and being planned, and the architecture is currently being figured out and finalized right now. Well, thank you so much for coming to this journey with me. And if you have any questions at all, please don't hesitate to reach out to me right here. I am Samia Durseti again, and I hope you all have a great day.